Composites. Composite materials are a combination of two or more materials that are different in chemical composition. The materials are blended to create a material with superior structure and better properties than the constituent materials. Composite materials can be a combination of various materials such as plastics, metals, fibers, or ceramics. The properties of composite material depends on the property, structure, and proportion of the constituent materials. Composite usually consists of two parts of the matrix and the reinforcements. The matrix holds the reinforcements, transfers the load to the reinforcements, and protects them from mechanical and environmental damage. Reinforcements carry most of the load and provide stiffness. Some composite materials exhibit better properties than the constituent materials, such as metals or plastics. Therefore, composite materials are preferred over the material in applications such as aircraft, manufacturing, space vehicles, electronics, and supporting goods.
Classification of composites. Based on the reinforcement techniques, composites are classified as fiber reinforced, structural, and particle reinforced. Fiber reinforced composites consist of thin fibers of material which are suspended in the matrix of another material. Matrix is nothing but it is a substance in which the fibers are suspended. The role of matrix is that it distributes the stress across the fibers and it provides an overall toughness to the structure. One of the most common example for natural fiber reinforced composite is bamboo, where the cellulose fibers are suspended in the matrix of lignin. Some commonly used reinforcing fibers are Kevlar, graphite, and glass. Role of matrix materials. In composites, the matrix phase serves important functions. First, it binds the reinforcements together and it transmits and distributes the external loads to the fiber. The second function of matrix is to protect the individual fibers from surface damage due to chemical reactions with the environment and due to mechanics ablation. And finally, the matrix separates the fibers.
Reinforced material composites. Composites are of three different types: particles, fibers, structurals. Particles are of two types: large particles, dispersion strength. Fibers are of two types: continuous fibers and discontinuous fibers. Discontinuous fibers are divided into aligned and randomly oriented. Structurals are classified into two types: laminates and sandwich. Composites are materials in which the reinforcement is responsible for higher strength. Two main forms of reinforcement used are fibers and particles. Fibers. The fibers are the materials for reinforcing. Fibers have high tensile strength, based on which the diameter and character of the fibers are as follow. Viscous. These are the thin crystals which are extremely large length to diameter ratios. Because of their very small size, they have a perfect crystalline structure and are free from flaws. Based on the diameter and characters, fibers are classified as follows. The fibers are either polycrystalline or amorphous material having small diameters. Fiber materials are generally either polymers or ceramic. Some common fibers used are polymer, ceramics, glass, carbon, boron, aluminum oxide, silicon carbide, etc. As you can see in the figure, they are unidirectional, bidirectional, discontinuous fibers, woven, aligned fibers, random fibers, and woven fibers.
Particles. The particles having size of up to 1 micrometer or more in concentration of 20 to 40% have been used in composites. Several metal particles such as tungsten, chromium, molybdenum, etc. can be suspended in ductile matrix.
Non-metallic particles such as ceramic can be suspended in metal matrix. Several matrix oxides and carbides in the form of particles are used to produce metal matrix composites, MMCs. Wires. Wires have a relatively large diameter compared to fibers. Typical material includes steel, molybdenum, and tungsten. The arrangement or orientation of the fiber concentration, and distribution all have significant influence on the strength of the composites. The types of orientation of fibers are shown in the figure.
So now let's look at the different types of composites. Based on the matrix material, there are three different types of composites: polymer matrix composites, metal matrix composites, and ceramic matrix composites. Polymer matrix composite. The matrix material is a polymer reinforced by ceramic. The polymer here may be an unsaturated polyester and epoxy or thermoplastics. The properties of polymer matrix composite is that they have high tensile strength, high stiffness, corrosion resistance, high fracture toughness. Applications of PMCs are it is used as a component in varieties of medical devices such as MRI scanners, C scanners, wheelchairs, and prosthetics. Reinforcements are glass, quartz, fiber, and Kevlar. Metal matrix composite. Metal matrix composites. The matrix here is an pure metal or an alloy, and the reinforcement is a ceramic phase. The most common type of metal matrix composites used are the aluminum matrix composites. Advantages of it are they have increased specific strength, specific stiffness, improved wear resistance, lower density, and these are also corrosion resistance. Ceramic matrix composites. They consist of ceramic fibers embedded in a ceramic matrix, forming a ceramic fiber reinforced material. These are used in extreme conditions. Applications of CMC includes high elastic modulus, low density, high temperature range of around 2000 degrees Celsius, and these have excellent resistance to wear and tear. These are used in aerospace sector and the energy sectors. Examples are glass and carbon fiber reinforced plastics.
Hello everyone, I am Akshaya. I am here to talk about the fiber reinforced plastics, that is FRP, and their applications. Now, what is fiber reinforced plastics? These are the plastics as a composite material made of a polymer matrix reinforced with fibers. There are many fibers: glass, carbon, aramid, asbestos, and wood. But the most common three types are glass fiber reinforced plastics, aramid fiber, and carbon fiber reinforced plastics. Now, first, what is glass fiber reinforced plastics? GFRP are the most widely used and the least expensive of all the fibers. High purity silica fibers as polyamide resins are used for applications where the temperature is as high as 3000 degrees Celsius. GFRO composites have very high specific strength. Next, the common type is. The common type is aramid fiber reinforced plastics. Aramid fibers are the testable where lightweight, high tensile strength. Kevlar 49 is the most common aramid fiber. The common matrix materials are the epoxides and polyesters. Next, the last common most type is carbon fiber reinforced plastics. Carbon fiber composites have much lower densities, higher strength, and higher stiffness to weight ratio. This composite has low coefficient of thermal expansion and this gives better dimensional stability. The commonly used matrix materials are epoxy, polyester, polyether ketone that is PEEK and polyether ketone that is PEEK and polyphenol sulfide that is PPS. Last, the advantages and limitations of composites. What are the advantages? These composites offers not only high strength to weight ratio, but also reveals exceptional properties such as high durability, stiffness, damping property, flexural strength, and resistance to corrosion by impact and fire. Then what are the limitations that is disadvantages of the copy materials? At high temperatures, the material strength decreases and deflection increases. These materials continue defecting under high heavy sustained loads, that is creeping. Impact loading during collisions can damage these materials. Thank you.
Composite is a material made from two or more different materials that, when combined, are stronger than those individual materials by themselves. Simply put, composites are a combination of composites. Coming to the application of composites, we have several applications regarding to it. Firstly, commercial aircraft. Use it for air conditioning, duct, radar dome, landing, gear door sets, ceiling panels, propeller blades, air brake, portable water tank, etc. Second application of composites is military aircraft. Used for speed brake, rudder turn iron, forward fuselage, elevators, horizontal stabilizers, landing gear doors, etc. When coming to the third application of composites, missiles. Use it for remote piloted vehicles, filament wounded rocket motors, wings, motor cases, etc. Application of composites. Space hardwares. Use it for antennas, trucks, support trusses, storage tanks for gases and fluids at cryogenic temperatures, etc. Fifth application of composites is automobile and trucks. They are used for drive shafts, bumpers, doors and window frames, starter motors, commutators, body panels, radiators and other hoses. Coming to the sixth application of composites is electricity and electronics. Use it for microphone housing, miniature electronic card holder, ribs to protect printed circuit boards, parabolic antenna, etc. And the final one is marine applications. Use it for small boat hulls, sonar domes, masts, decks, submarine masts, the racing yacht, plates in nuclear submarine lead, acid batteries, etc.